From ContainerDays Hamburg, this video is proudly presented by DAX IT.
Yeah, my name is Moritz Wanzenböck. I work at Linbit, which is based in Vienna, Austria, and we're working on open source software-defined storage solutions and integrations. And my specialty is the integration with Kubernetes, but we also offer like integrations with other orchestration solutions. From my personal opinion, the Kubernetes one is the nicest one to work with, but maybe I'm biased. No. So from my history, my first encounter with Kubernetes was back in 2018. Then I just had it set up for me by one of our admins and started to work it and provisioned my first volume. I think it was Ceph back then, and didn't think much about how that works. Later I switched to Linbit, and then I had to learn how all this container storage stuff works. And through that, I managed to become a maintainer of the open source Piraeus Datastore project, which is kind of the open source software or our open source solution. And it's on GitHub, and it's a CF sandbox project, so it's going to be open source all the time. You can also find my personal GitHub there. So what I actually want to talk about in this talk is what even you can do with container storage. So it's been evolving for over 10 years. Kubernetes 1.0, which is not even the first Kubernetes version, but it's released over 10 years ago. And it had a fixed set of 7 storage or volume providers. And you couldn't even do dynamic provisioning of new volumes there. Everything had to be set up manually. Now with the latest Kubernetes release, we are up to 22 volume providers and a container storage interface, which is kind of the one you want to write new storage providers in right now, actually has over 100 sub-providers. So there's now a lot of choice. And there are a lot of new features that get added all the time. Sometimes they get added to just some specific storage providers. But over time, with the container storage interface, these kinds of features get standardized, and then so everyone can benefit from these features. And so I want to highlight some of them. So just to give you a quick overview how one storage provider would work, and I'm most familiar with Piraeus Datastore. Like, we want to benefit from all the Linux storage goodies. It's all fully open source. We pride ourselves that we are pretty low overhead on the resource requirements. We support through the existing Linux solution like LUKS encryption at rest, deduplication, caching, RAID, software RAIDs, and so on. And we want to bring all of those storage solutions to the cloud with on-demand volume provisioning, and what will follow in this talk later with snapshots and other goodies. So as I was saying, this is just an example, but for Piraeus Datastore, we have one node agent, and on there you have on the lowest layer, you have the actual hardware. Then on top of that, we have some kind of volume management, and then encryption and caching and so on. On top of that, because we don't want to, we want to be in the cloud, we want to migrate data between different nodes and so on, or replicate between them. We have DRBD, which does the replication in kernel, so that is also low overhead. And to orchestrate all of that and provide a nice REST API and UI, we have LinStore. But actually, you don't even need to know all of that, because what we have now with the unified storage abstractions with Kubernetes, you only really need to know 3 things to get started with container storage. So these are storage classes, persistent volume claims, and persistent volumes. And of those, once you have set up your storage class, you only really need to use persistent volume claims. So here on the right, you can see an example of a persistent volume claim, and the only thing you really care about is, okay, I want to have a volume that is 1 gigabyte in size, and you give it some name, and you set some access mode, in this case that, that it can be used by one node at a time. And so this is kind of a nice independent interface. If you later switch over to a different storage provider, you can just reuse this persistent volume claim. Maybe you need to change the storage class name, but it will work the same. And this is the kind of the power of the standardization we have with Kubernetes. But it also means that, if something is not in the standard, you're automatically on the side of, oh, now you have been locked into a vendor. So it's good that new stuff gets to added to the common standard all the time. And this is what we will see now. So previously, a lot of storage providers already supported snapshots and snapshots in the backend. And at some point, the Kubernetes storage working group got together and defined, okay, how do we want to work, want snapshots to work in Kubernetes? And basically, they came up with the same kind of structure that we have with persistent volumes. So you again have 3 types of resources, which is the volume snapshot class, which acts just like a storage class. So it's kind of the provider-specific configuration for how snapshots work. We have a volume snapshot content, which is like a persistent volume, which you mostly don't need to care about if you're if you're just a user. And then the volume snapshot object, which is like the PVC where you request, hey, I need to have I want to create a snapshot. And here again on the right, this is kind of the minimal example you need to use, or you can use. And with that, you get a snapshot and can use that. But it also kind of this flexibility allows to have different kinds of snapshots. So for the example in Piraeus, we support different types of snapshots, which I will call an in-cluster snapshot and a remote snapshot. So in-cluster snapshot, all the data is stored local to the volume or local to the node where the volume is also deployed. And this is fast and cheap because it's just using our underlying storage technologies, either LVM or ZFS. And so it's really cheap and fast to make. You can use it to, I don't know, make local recovery tasks. But it doesn't prevent or it doesn't help you if, I don't know, your cluster gets destroyed because some fire breaks out in the data center. And for that, you really need offsite or remote snapshots. And that means that the snapshot gets created as before on the node, but then gets uploaded. And in our case, we can either do that on some object store like S3, or even a different Piraeus or Piraeus installation, so a different Kubernetes cluster. And this is then useful for disaster recovery. And the only kind of difference between the snapshots that you need to make is you have 2 different volume snapshot classes. And when you create a snapshot, you just have to select one or the other, one like local and one remote. And this is even more powerful when you consider that you have other tools that can now integrate with this volume snapshots logic. And so there are tools like Velero and I think Kasten.io and others are available that automate all of those tasks of volume snapshot creation for you. They do even more, like you can snapshot your whole cluster. It will kind of compile all your workload resources, your deployments, your config maps, and so on. Put them all in a bundle. It will create a volume snapshot and then send that to some remote location, so S3. And if we use the volumes, or if you use our remote volume snapshot, then you can store the snapshot content also at the same remote, and so you have all the cluster backed up to that one location. And these tools then also offer the equally important part of actually restoring from the backup, because if you can't restore your backup, then you don't have a backup. So they also take care of doing kind of the reverse operation, put your cluster back like it was before. What's even more interesting is that these tools also offer an option if the storage provider, unlike us, we support this kind of remote uploading directly, but sometimes your storage provider does not have that. It only has this kind of local snapshots that can only be used in one cluster. So they have a strategy for that, and that basically takes a local snapshot, creates a new resource from that snapshot, so it basically creates a second copy, and then starts uploading the content from the volume, like with tools like rclone or Copia, to the remote location. And this is quite nice because now you're not even, searching for, or you can keep using your storage provider, even if it doesn't directly do this backup solution, but you still have a backup through this Velero or other tools. Now, what is the downside of that? If you're doing like this restore and then upload approach, is you spend a lot of time uploading the volume content. If you have a large volume, terabytes, maybe petabytes, I don't know, then depending on your uplink, but it most of the time will take a lot of time. So what the tools actually want to do is only send what changed since the last backup, so kind of an incremental backup. They use different strategies for that, but depending on how large the volume is, this is again very slow because they have to kind of crawl your local content and compare it to the remote content they already have and see what changed. So on the other side, us as storage providers, most of the time we already have that information because we work on a different layer. We know how our storage is set up. So we often can provide quick kind of diffs between the different volumes. And so wouldn't it be nice if we made this information available and so that these tools can also speed up their own work? And this is what changed block tracking is, which is very, very new. It's a new addition to the CSI standard. It's an optional feature, so not every service or not every storage provider will use that or even can provide that. But basically what it does is if we have the information of, okay, I want to compare this old snapshot with the new snapshot, please tell me what changed, then we storage provider can implement this interface, and then tools that make use of that can use that to speed up their own kind of diff process. They only need to ask us what changed, and if nothing changed, then they don't need to upload anything, or only need to upload a small diff. And for the fallback, their old strategy is still valid. If the storage provider does not implement that, then yeah, tough luck, but the old ways still work. Another nice feature around snapshots is if you're running a workload that makes use of multiple volumes. So you could consider, I don't know, you have your pod that has kind of a data volume which is large and rather slow, and you need to also store some metadata for that data, and that kind of changes more often. Then you have like a faster disk for metadata. But if you take snapshots the old way, it's like, okay, Kubernetes creates this volume snapshot requests, but the way Kubernetes works is, the resource is created, but that doesn't mean that instantly everything gets snapshotted. But it's rather a process of some controller will come around, see, oh, there are new requests for snapshots, and then they will maybe work through those snapshots one by one. And that could lead to data inconsistencies in such a case, because like your workload will still continue to run. Maybe you request a snapshot of both the data and the metadata volume, and the snapshot for the data volume gets created first, and then some writes happen to the data and metadata device, and then like maybe half a second later, the snapshot for the metadata is created, and if you then try to restore that, you kind of have an inconsistent mess, and depending on your application, it might even refuse to start from that because there is something in the metadata that is not referenced in the data, and now you have kind of an unusable snapshot or backup, and what are you going to do with that? So we came up with a new standard way for that, which is called volume group snapshots. They are currently in beta on Kubernetes 132, and I guess they will be stable or generally available very soon, which is basically another kind of resource where we can instruct us, or me, like while I am the storage provider, hey, these volumes should be snapshotted in a consistent way together. And the way this works is it looks very similar to the normal volume snapshot, but instead of listing just one persistent volume claim, you list this kind of selector, and then it will request that all the volumes matching that selector get snapshotted in a consistent way. And as a user, or when you want to use them in the backend, they create just regular volume snapshots that you can restore using the regular tools. The caveat with that is it's still in beta, so not many people are right now supporting that. For Piraeus, we want to have that support soon, so it should be landing next month, I think. Yeah. Then in some scenarios, you're not really interested in creating a snapshot, but you just want to have a quick copy of the volume. And you could use snapshots for that. For example, you need to take a database dump, and for some reason you have such a large database that it's creating a regular dump on the production environment would somehow impact the performance of your regular database. So what you could, or second example, you use something like KubeVirt to run virtual machines. And the way KubeVirt works is that it creates the volume or VM images as persistent volume claims, and if you want to instantiate a new virtual machine, then it will create a copy of this persistent volume claim. And by default, what it does is it will create a snapshot and then restore from that snapshot. But actually, we can skip a step because Kubernetes supports direct volume clones. So in your persistent volume claim, you can specify a data source, and this data source is usually a snapshot, a volume snapshot, but you can also directly specify a persistent volume claim, and then the storage provider will see, okay, I need to clone this volume, and does that directly in the background, no snapshots involved, you don't need to clean up anything else, and you just have a second copy of the data on the volume. And this actually pairs nicely with ephemeral volumes, which is another new feature that I think not many people will know about. So you have kind of these persistent volumes that you create manually by creating a PVC, or maybe you're using a storage stateful set, and there you create a volume claim template. But actually, since a few Kubernetes version ago, I don't know exactly when it was stabilized, you can use these ephemeral volumes where you can create an volume claim template directly in the pod definition, and then this persistent volume is only there for the lifetime of the pod. And what this does is, like, maybe you have some periodic job that does a database export for you, and for that you clone the volume of the database, of your main database, and you don't need to persist this volume anymore, so you just put it in an ephemeral volume on your exporter job, and then it will automatically clean up once the pod has finished. And you can also use it as a kind of better empty-dir volume. So if you're using empty-dir volume right now, you have kind of a binary choice. Either you can make it, you can use it backed by a temporary file system with memory, but then you're consuming memory of your node host, and if you're writing a lot of data on there, you probably run out of memory eventually. Or it's backed by whatever you have configured on the node on, I don't know, /var lib kubelet or something like that. So you are kind of limited in there. But perhaps if you have a storage provider that already has node local storage, and that is very fast, you can also use that to have empty dir volumes there, and then you're not that limited with the size those volumes. And even then, a new topic is volume populators. So here we have the data source reference is another persistent volume claim, but actually in there, in this data source reference, you can write anything as long as there is a controller that kind of knows what to do with that information. And this is used, for example, in KubeVirt with the containerized data importer. If you have not used KubeVirt, it's a bit magical, but one thing you can do with that is you can upload local virtual machine images or download them from the cloud directly to some persistent volume claim in the end. And the way it does this is with this volume populators. So you request a PVC, and it has this volume, or it has a volume populator set as the data source. And so the volume populator knows, oh, I need to provision a new PVC with this additional information. Could be KubeVirt, someone wants to upload this machine image. So it creates a pod. That pod then has its own persistent volume claim and its own persistent volume that is bound to this persistent volume claim. It starts writing whatever it needs. So it can download something from a backup location. It can wait for something to be uploaded through an HTTP server it exposes. But at the end, kind of the pod is finished. It will stop. The persistent volume claim that is bound to this one specific persistent volume is removed, but the persistent volume is not removed. It is instead rebound to the persistent volume claim that you originally created, and suddenly you have a new volume that is no longer empty. And that enables KubeVirt to do other interesting stuff. So KubeVirt, for example, can migrate storage between the different storage providers. So you can have your volume VM images on some super secure, triple replicated storage. But if you need a super efficient, fast to start up virtual machine, then it will choose the best option to kind of create this new persistent volume. And that can either be a direct volume clone or restore from a snapshot if you're using kind of the same storage provider. But if you can have multiple storage provider in a cluster. And so if you're switching between these storage providers, then KubeVirt will say, okay, then I guess the best I can do is copy that by running dd or some other command to the new volume. So this is kind of, if you're used to some other VM orchestrators and so on, this is sometimes a bit magical that this all works. And it also kind of allows a changing of volume parameters when it is otherwise not supported. Speaking of changing volume parameters, right now, if you create a storage class, you can't change it afterwards. This is a bit awkward if you're just starting out with persistent volumes and you create your first storage class and then maybe you see, oh, this setting is not actually what I wanted. You can't just apply it again. You get this nice error message that update to parameters are forbidden. And this is a bit annoying, and sometimes you would wish that, you know, you could change the volumes a bit more. So there's a new solution for that, which has been stabilized in the latest release, which is volume attribute classes, which are like storage classes, but actually dynamic. You can change them at runtime. And so instead of just using the storage class name, you can also write a volume attribute name to your persistent volume claim. And this will be kind of merged, depending on your storage provider, with whatever you have set in the storage class. So yeah, as I said, this has been generally available since Kubernetes 1.34. And kind of the list of what you can change with this volume attribute classes depends again on the storage provider, because it is kind of a specific thing on what you can set on your storage provider. For Piraeus, this includes replication setting and some settings around how automatic volume handling is handled. But I have to say, this is so new, it's coming soon. One thing that is often requested, and I'm surprised that it still does not, that there is no kind of general solution for that in the Kubernetes world, is some kind of quality of service settings for volumes. You know, we have in Linux, we have all those kinds of nice tools with C groups to limit pods and containers to only use a specific amount of resources on your nodes. And one of those would be kind of how much they can, or how fast they can write or read from a volume. But for some reason, this is not yet standardized, and maybe this can be standardized with these volume attribute classes in the near future. Yeah, so I actually want to keep it short. I would have a bonus topic, but I think I've already told you enough about. So container storage can do a lot. You can probably try it out. If you have not already, you can try out different storage providers and find out, and you find one that fits your use case. The abstractions we have with kind of persistent volume claims and volume snapshots means you're not really locked into one vendor. Once you started all these manifests, once you've changed the storage class and volume snapshot class, yeah, it's pretty easy to switch providers. If I have specific recommendations, volume snapshots are very useful if you want to have a kind of production environment where you're also concerned about creating backups. There, take a look at Velero, which is a nice and open source tool to automate the backup schedule. If I had to pick one provider, but others are available. Ephemeral volumes exist and are useful. Volume attribute classes may fill a gap with storage classes where perhaps after 3 days you recognize, you know, at that volume I created, which has only one replica, I actually really need that data. So it's better if I switch to create, or if I have that with 3 replicas. And as a bonus, which would be on the bonus slides, to make the job of your storage providers easier, is on the storage class you can set the volume binding mode, and the default mode is immediate. So once you create a persistent volume claim, it will immediately create a volume. Switch that to wait for first consumer. So it waits until the first pod is scheduled to create this volume, which allows us as storage providers to actually make some informed decisions on where this volume will start. If you want to play with a full-featured open source container storage solution, there's the link to Piraeus.io, and you can get started. If you need enterprise support, we at Linbit also provide that. So thank you. And are there any questions?
The first one would be, does Piraeus support RWX support or access?
Not right now, but we will have that feature in 1 month, maybe 2 months tops. So it's on the very near future.
Perfect, thank you. The second question would be, how can you make sure the data in the snapshot is consistent? Shouldn't the application writing to the PVC should be aware when a snapshot is taken?
Yes, and that is kind of, some storage providers. I was at the talk for Podworks earlier this day, and they have that integration. If you're using Velero also supports this kind of integration where you can set specific hooks for when your snapshot is taken, please first run your special MySQL command to flush the database. What we do is we only ensure that your file system on the volume is consistent, but no further hooks from there. But if you use Velero or some other integration, then you have that there.
Nice. Erwin is asking, in your example, the group snapshot was demonstrated with a single port. Can it also span multiple ports to ensure a consistent snapshot across them?
Yes, it can. So you can use, on the selectors, you can basically create a volume snapshot of all volumes within a specific namespace. Yeah, it will work with multiple ports.
Great, thanks. Would not an XFS-based storage solve the incremental backup issue?
XFS, kind of. You have these different kind of strategies, and like Velero already does smart things to optimize this incremental backup solution. But for some kind of workloads that's not possible. You can also back up your, KubeVirt VMs, and then you're not talking about making incremental snapshots of some file system volume, which XFS is, but you are making incremental snapshots of some block storage, or perhaps you're running MinIO to provide object storage, and that also consumes block storage. And then you don't have the ability to use like XFS features to make incremental snapshot detection.
Interesting. The next question would be, now it's jumping. The snapshot volume class is Kubernetes official and beta, or did I see that wrong?
The snapshot class, it's provided by the Kubernetes storage working group. So it's not part of or depending on which Kubernetes distribution you're using, it may not be part. So if you're using kubeadm to create the cluster, it won't be there. You need to find the Kubernetes storage SIG, and they have kind of all the different controllers that you need. And in there you have the CRDs for the volume snapshots and group volume snapshots and so on.
Thank you. The next question, can we expand volumes created using populators like data volumes?
Yes, you can expand those volumes. They have a regular storage class. What you can't do is like run the populator again once the volume is provisioned. That, to my knowledge, does not work.
Is there a way to share ephemeral? Sorry.
Ephemeral.
This is a word that breaks my tongue. Ephemeral. volumes between pods and the same deployment as ARWX?
Share is a bit difficult. So for the lifetime of the pod that originally created this ephemeral volume, it will be a regular PVC in your Kubernetes namespace. And you can reference that persistent volume claim that has some generated name in another pod manifest. And I believe that would also keep it alive if the original pod went away, because it's bound to a pod, then you could share it, but I don't think that's the intended way to use that.
Okay. And the last question would be, how does a snapshot differ from a Velero backup of a volume?
So kind of to create a Velero backup of a volume, first of all, you need a local snapshot, because otherwise what Velero would need to do is, to my knowledge, maybe they have some magic that I don't know about, but they would need to stop the current pod that is using the volume, copy all the content to a different location or upload it, and then they can restart the volume. So you need at some point, you need a second copy, and the way that Velero does that usually is you create a local snapshot of the volume.
Thanks for answering all the questions. Thanks again.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.